welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. Hi everyone, welcome to the House of ZK Radio podcast. My name is Alice. I am one of the hosts for House of ZK Radio, and I'm joined here today with White, who is co-founder of 6block, and very excited to have you here today, White.
Yeah, hello everyone. Yeah, so my name is White, and I used to be a blockchain researcher from maybe 2015, and at that time, as you know, the first zero-knowledge proof-based project, Zcash, has just launched its mainnet. So I just dived deep into the technology of zero-knowledge proofs from then on. And then I just started up a company named 6block.com. 6block.com is just a mining company. It provides many solutions for mining different projects. For example, we used to mine Filecoin, Ironfish, and as well as Aleo. So then in the Aleo ecosystem, we just provide the solutions of the mining pool. It's called ZK.Work. Right now, we possess 30% of the total computing power in the Aleo mainnet. We used to participate in Aleo from day one of the Aleo testnet 2, testnet 1, 2, 3, and the testnet beta. And we have achieved a lot of rewards from them. For example, we achieved the second place in both testnet 2 and testnet 3, and then we also achieved the 7th place in testnet beta. And right now, the second largest mining pool in the Aleo mainnet. So we know a lot of, we know about Aleo even deeper than some researchers and some developers of Aleo. So we know how the algorithms has changed during the past 3 years of Aleo, and we did a lot of optimizations. And for me, I'm a co-founder of the company, and I used to be a researcher and a developer, but later I have a team who is good at optimization, zero-knowledge proof optimization. So I'm just do some podcasts and some presentations to tell more about the team. Yeah, that's that's my work.
Nice. And curious to hear, what kinds of opportunities do ZK proofs bring to mining? What sort of incentive models are there, and what's the opportunity over there?
Yeah, because the mining market is very big. You know that the Bitcoin is the biggest cryptocurrency which supports mining, and the proof of work of Bitcoin. There are a lot of computing power all over the world. They just consume electricity and to generate bitcoins. But the traditional algorithm for mining is just simply hashing. Yeah, which means SHA-256. The algorithm is really simple. So you can see that there are a lot of ASICs, a lot of special designed hardwares in the market. But when the algorithms change to zero-knowledge proofs, it brings a lot of challenges to the design of the hardware as well as the optimization of the software. I think the main difference between the zero-knowledge proof mining and the traditional mining is that you need to do a lot of optimizations, a lot of accelerations to the algorithm, because the algorithm is much more complicated than before. You need to generate the circuit of the zero-knowledge proofs. You also need to generate the proof, and especially in the proof generating part, it also needs a lot of RAMs of GPUs. So it's totally different, and so we did a lot of optimizations before in the Aleo ecosystem, because we know about the zero-knowledge proofs very well. And I think it also brings a lot of challenges to miners. We know miners all over the world, but right now in Aleo ecosystem, they are using some GPUs which are used, for example, to generate some AI, compute some AI projects. They just use the same GPUs to mine Aleo to generate those zero-knowledge proofs. And as far as I know, there are also some hardware designing companies who are designing specific ASICs for the zero-knowledge proof generating. So I think that's a big market.
Yeah, and there's, of course, you mentioned some challenges relating to acceleration and also optimization as well. Yeah, and also very curious to hear why you guys chose to build specifically on the Aleo ecosystem. What sort of advantages or benefits did it bring?
I think Aleo is it is first project that supports to use their knowledge proofs to mine coins, and before that, although many projects brand themselves as their knowledge proof project, for example, the Layer 2 Scroll, and for example, Ironfish, but their mining algorithms are not. They don't use their knowledge proofs for their mining. The algorithms is totally different. It's not their knowledge proofs. And the only project before which use their knowledge proofs to mine coins is Filecoin. And Filecoin uses their knowledge proofs to generate a proof of the offline off-chain storage. So, but when it comes to Aleo, it's get one step further. It uses their knowledge proofs to prove the validity of all the transactions on its blockchain. I think it's different because, as far as you know, the Vitalik also gave a roadmap to Ethereum that he aims to prove the Ethereum, the whole blockchain, the validity of the whole blockchain, every transaction on it, using zero knowledge proofs. And I think that's the future of all the blockchains. Because right now, when you put too many transactions on the blockchain, the performance of the blockchain is limited. For example, the TPS of Ethereum maybe is 7 or 10. That's so limited. It cannot have a bright future for online transactions as well, DeFi, the apps. So if you use the zero knowledge proofs to prove the whole blockchain, then a blockchain of a lot of, for example, 1 million, 1 trillion transactions can be verified at once. Yeah, you can verify one proof to verify the validity of the whole blockchain. I think zero knowledge proofs is a key to improve the performance of a blockchain to contain a lot of millions, trillions of transactions. And to achieve this, I think the way how we generate those zero knowledge proofs is important. If we can generate proofs even faster and faster, and then we can achieve this goal in a near future. So I think that's very important to use zero knowledge proofs to generate the validity proof for a blockchain. Yeah, that's really important.
Yeah, and we're seeing like trends where the proof generation costs are becoming lower and lower, and we're almost reaching a time where perhaps even real-time proving can be achieved in the future, and that'll definitely open some more applications there. So very exciting. I was also wondering if you could talk a bit more about the mining experience for users. What makes a high-quality mining experience, and also, like, for example, relating to lowered costs, maybe high performance, network stability. Just curious to see your thoughts on what makes an optimal mining performance, and just applying that also to ZK. So both like optimal mining experience in general, and then how that relates and how ZK can be incorporated there.
Okay. From the day one of the Aleo mainnet, we noticed that the group of miners, it has changed in Aleo. Because we expected that the miners are from, for example, Bitcoin or from Filecoin miners, but actually when the Aleo mainnet launched, and we found that all the miners of Aleo are from Ethereum, which means as far as you know, when the Ethereum switch its network to 2.0 and it switches from proof of work to proof of stake, a lot of GPUs stay unused after then. So we found that these GPUs just come to Aleo when Aleo launches mainnet, and those miners, they don't know too much about neural proofs. They don't know much about Aleo. They just need to learn more about the blockchain as well as the mining. So at that time, we also developed the Aleo.info Explorer to show them the data on chain, to tell them more about the technology. And then they get to understand Aleo more and more better. To tell about the performance, they are also trying to improve its performance. But Aleo, because it's used zero knowledge proof mining, and it has several challenges, something different from before, especially when because the mining algorithm of Aleo is like that. For each epoch, one epoch takes 20 minutes. For each epoch, the Aleo will generate a puzzle. We call it a puzzle, but it's actually a circuit, a zero-knowledge proof circuit. And for each 20 minutes, it will generate a random puzzle for users to solve. But the difficulty of each puzzle changes, which means for one epoch before, the difficulty of the puzzle is very difficult. But one epoch later, the difficulty is very low, and so the hash rate of the Aleo network fluctuates up and down all the time. So that's hard to understand, because in other blockchains before, for example, Ethereum, Bitcoin, the hash rate keeps constant over time. But in Aleo, because in every epoch, miners need to solve different puzzles, so the difficulty is totally different, and the hash rate goes up and down, and so people are wondering why this happens. So we just cost a lot of time to tell them the reason behind it, because the zero-knowledge proof algorithm is totally different from simply hash. Yeah. So let's take a lot of time, but finally we just come up with a benchmark of our software. And I think right now, among all the mining solution providers in Aleo, we are the only one who just have the benchmark of the software over different types of GPUs. For example, the 4090, NVIDIA 4090, NVIDIA 4080, and other providers, they don't have such a benchmark. And we also trying to figure out which type of GPU has the highest price performance. And finally, we find that the 4090 is best, because in one aspect, the 4090 itself, it has the highest performance when using the same electricity. On the other aspect, that the RAM of the 4090 is really high. It can also be used to generate some AI and other to do other works. So I think the NVIDIA 4090 has the best price performance. Yeah, that's all the challenges and problems we faced before.
I see. Yeah, and just curious on the hardware acceleration side, you mentioned that you were exploring different GPU models. I'm wondering if there's any other types of hardware that you also explored, and maybe some trade-offs or limitations between each one.
Yeah, I think when we talk about the NVIDIA GPUs, there are a lot of models we can choose. And right now, we compared all of them. Right now, we find that the 4090 is the best. And when we talk about, there are also many AMD GPUs in the market. We can find that we are also the only provider that has a solution for mining with AMD GPUs. And we compared all of them, and we finally found that actually they don't have too much difference between each other. And I think maybe right now, for a relatively long period, and all the zero-knowledge proofs in the crypto area are generated by GPUs. But we also exploring the possibility to use, for example, FPGAs or ASICs to generate zero-knowledge proofs. And you can see there are also a lot of other companies to do that. And we found that finally, maybe 1 year, half a year, or 1 year later, right now, maybe more than 99% of the GPUs zero-knowledge proofs in the market are generated by GPUs. But finally, they will be generated by ASICs, because as far as we know, a lot of companies are designing specific ASICs for the Aleo and other zero-knowledge proofs generating environments. Yeah.
Yeah, I see. So in the future, do you suspect the GPU-based approach to be more dominant, or the ASIC-based approach? Or do you see like a combination of, say, providers using FPGA and then using GPUs as well as ASICs? What are your predictions in terms of the types of hardware that we'll see being used in the future?
I think both ASICs and the GPUs has its own market, because the algorithm of zero-knowledge proof is changing. You can see at first the Zcash is using gross knitting, then the algorithm changed to be Planck, and in Aleo it's Malin, and there are, for example, FF Planck and ZK Snark. There are many different algorithms. So ASIC cannot deal with so many different algorithms, but the GPU can. So as the developing of the different zero-knowledge proof algorithms, I think the GPUs has its own market, and that market cannot be dominated by the ASICs. But if the algorithms just goes to stable, for example, ZK Stack or Planck just dominate the market, people find that this algorithm is better than all the others. Then at that time, I think ASICs will has its market. The market of ASIC will get bigger and bigger, because the algorithms will not be changed for a long time. So finally, in conclusion, I think both GPUs and the ASICs have its own market cap, and it depends on whether the algorithms is changing or not. Yeah.
Got it. So it's not like one is competing against each other, or we'll see like one overtaking the other. They each have their own kind of markets and their own uses.
Yeah. When we talk about the AI, there are also many companies who is designing some ASICs for AI, but AI algorithm is also changing. So right now you can see that the NVIDIA GPUs just dominate the AI market. Especially it has its own programming language, CUDA. So. But when the algorithm or AI is going to stable, and I think at that time the ASIC for the AI will be developed. Yeah, I think AI and zero-knowledge proofs are similar. They are similar.
Yeah, so we can maybe see what the trends we've seen in AI kind of be applied to ZK as well. Yeah, interesting. Also very curious to hear about, you talked a little bit about this earlier, about network fluctuations. So specifically for ZK.Work, I'm wondering how you guys address network fluctuations, especially within like your pool service nodes.
Okay, the network, the hash rate fluctuation is very something new in the Aleo network, and it also brings a lot of challenges to our design of the mining pool. Yeah, because as you can see that when the puzzle of the epoch getting more difficult, and we will receive fewer solutions from miners, but the time we cost to verify each solution will getting just longer. But when the difficulty of the puzzle getting lower, there are more solutions which are submitted to our mining pool, but the time to verify each solution will get shorter. So it means the computing power which we use to verify all the solutions submitted to the mining pool just changes over time. So we change the traditional mining pool design, the architecture, to a scalable one. We simply use many servers to verify all the solutions submitted to the mining pool. By doing this way, because as you know, the difficulty of a puzzle can change maybe 10 times over different epochs. So we need to bring a lot of servers to verify all those solutions submitted by the miner, and so the total architecture of the mining pool is no longer a fixed one, no longer a constant one. It's need to be scaled over time. When there are more miners, there are more solutions submitted, we need to use more GPU, more servers to verify all those transactions. So I think that brings a lot of challenges to the design of the mining pool, especially at the early stage of the mainnet. Our mining pool at the time, when more and more miners, especially when the price of the Aleo goes up, more and more miners just go into our mining pool. Our mining pool gets stuck at that time because the burden is too big for the mining pool, and we add more servers to the mining pool immediately to solve this problem. So I think that's very important. Even when in the future we use the knowledge pools to prove not only the Aleo blockchain, to prove more and more, for example, the smart contracts running on Aleo, and I think that's very important to such a mining pool to provide computing power to all these tasks, because the difficulty is changing. For example, today on Aleo, maybe there are 1,000 smart contract calls right now, but maybe in the future there are millions smart contract calls. If you want to use the knowledge proofs to prove all of them, I think the time to verify all those proofs also changes. So we need to build a fully scalable mining pool to deal with all these tasks, because the tasks is changing, number of tasks is changing. So that's the main difference between our own mining pool design and the other traditional mining pool design. Yeah.
Oh, is that scalability part?
Yeah, scalability is really important.
Yeah, and in that scalability portion where, say, the number of miners as well as the type of work can be increased, how does the incentive models or incentive mechanisms that's used within that pool change as well? How is that affected?
Oh, actually, right now we are also using some traditional rewarded distribution algorithm. Yeah, for example, PPLNS. Yeah, that's really old algorithm, which means if you submit a solution which can generate a reward, and the other solutions generated near you can also get that, can also share the reward. And right now we do not have some specific design, but I think in the future this is different, because right now in Aleo the mining algorithm of Aleo just they also need miners to generate some unused proofs, which means you need to try different nonces to generate a proof that meets the difficulty. So a lot of proofs is unused actually. But I think in the future, we can consider something like useful proof of work. For example, right now as far as I know, all the computing power of Bitcoin and Aleo, actually the computing power is wasted because they don't need the proof they generated doesn't bring any meaning to the network. But I think in the future, all the transactions on the Aleo blockchain and as well as Ethereum can be proved by Ethereum. So I think at that time, all the zero-knowledge proofs is useful. They just prove something. They can be used. So at that time, I think the reward model needs to be changed, because we need to reward those miners in a different way, because all the proofs is useful. Yeah. So at that time, I think the mining algorithm of the blockchain can change from unused proof of work to useful proof of work.
I see. Yeah, I like how you phrased that.
Yeah.
And I'm also curious to hear about your general vision and predictions for ZK-based mining in the future. What sort of challenges and limitations? You also mentioned that there were some like limitations relating to optimizations, hardware acceleration. But I'm curious to see and to also hear about what challenges are we currently facing right now, and then like what we need to do to address them to make sure we have the future that you see for ZK-based mining. Just wanted to hear basically about your predictions for the future.
I think for miners, the only thing they need to do is just they need to get to know more about the zero-knowledge proofs, because right now all those miners, they don't know too much about it. Yeah, just like maybe in the early stage of Bitcoin, because many miners don't know how the Bitcoin works. They simply know they just use some ASIC GPUs to mine it. They get coins. They provide GPUs, provide hardware. They get coins, but they don't know the underlying technology of it. When it comes to Aleo, I think the threshold is getting higher, because if you don't know the underlying technology, if you don't know how it works, you cannot have the best performance. For example, as I know a miner, he doesn't know too much about Aleo, so he's keeping asking questions in our community, and we spend a lot of time to explain all the underlying technology to him. And so I think as the zero-knowledge proofs are getting more and more widely used in the blockchain area, I think for miner, you need to get to know more about it, so that you can grasp the challenge, grasp its opportunity in the future. And for mining pool, I think we need to consider more about to have a mining pool that supports zero-knowledge proofs. I think in the market there are many different projects who claim that they want to build a computing cloud, a cloud for zero-knowledge proofs. But I think a few of them just start to do it. They simply tell stories, make presentations, and telling stories of it. But I think we are the first one to do it. Actually, to build a mining pool, whether you call it a mining pool or a cloud platform. Yeah, it's just a platform for many different GPU owners to generate proofs. And we are the first one maybe have a platform that contains maybe 100 giga hashes per second. I think a lot of proofs are generated and submitted to our platform. I think more and more service providers like us need to consider how to implement the mining pool or platform to connect GPUs and to receive those proofs and to verify those proofs in a platform. I think that's what we need to do right now. Yeah.
Mm-hmm. Yeah, and I like how you emphasized on the education-based focus as well, especially for these miners, like you mentioned, how maybe some of them don't have enough knowledge around like the ecosystem on Aleo or like for ZK, for example. So a big part of the adoption comes from just the education aspect of learning, like for example, the ecosystem that you're using, but then also more about ZK.
Yes, I also did a lot of tutorials as well as some podcasts, some videos to tell people how the zero-knowledge proof what it is, how it works, and what is the difference between different ZK-based projects, for example, Aleo, Ironfish. What's the difference between them? And I think a lot of people just watch it, and it helps them a lot. Yeah. So finally, when they know more about the technology, they are more interested to participate in this project. Yeah.
I see. Yeah, and just as a last question before we close today's session, I'm wondering if you have any advice for our audience, or if you have any announcements you'd like to make on behalf of ZK.Work and 6block.
Okay. I think in the crypto area, the proof of work algorithm, proof of work consensus is something really important. As you can, although you see that the Ethereum just changed from proof of work to proof of stake, but I think it's not. We cannot consider it's a successful or fair change. I think you can see that the price of Bitcoin is getting higher and higher, but the price of Ethereum is just stay at the same time, and it's even not get the all-time high. Yeah, from now. Yeah, and I think proof of work is very important to support the value of a cryptocurrency. So that's the reason why the price of Bitcoin is so pumped up. Yeah. So I think, but for the proof of work, the algorithm itself is changing. It changed from the simply hash SHA-256 hash into more complicated zero-knowledge proofs and more useful proofs. So I think to miners, we should consider that future. In the future, all the blockchains, no matter it's Ethereum or Bitcoin or Aleo, all these blockchains can be proved by such a succinct zero-knowledge proofs, and you can verify a whole blockchain with a lot of millions, trillions of transactions in maybe one second. And that's the future design of a blockchain. By doing this, we can just send more and more transactions on chain. The TPS of blockchain can achieve a higher level. For example, one TPS can be 1 million per second. And I think we cannot change. That's an unchangeable future of the blockchain, the design of a blockchain. So I think zero-knowledge proof is really important, and all the miners can consider how to change their hardware to be more suitable to the zero-knowledge proofs. Yeah, that's what I want to say to the public.
Yeah. Thank you so much, White, and very good to hear your perspectives on just like the future relating to ZK-based mining, your thoughts on the hardware that's needed as well, and what you guys are working on with building those scalable mining pools. So all very fascinating, and yeah, thank you so much for being here today.
Yeah, thank you. Thank you.
Thank you.